Supplemental math videos from Circle Christian School.
Now using the two-column proof in geometry. So what's a proof? Something that philosophers had argued for centuries. As a matter of fact, the things of mathematical origin really didn't come from, hey, we see math all the time. It really came from the fact that we had philosophers who made the science and saw that things were happening, kind of that if I think, therefore I am kind of thing. They philosophized all sorts of little things, and then they had to prove the reason why they felt the way that they felt. Now, the father of geometry is Euclid. As a matter of fact, we call the geometry that we're doing Euclidean geometry. This proof is going to be a little bit more geometrical, involving geometry. There are certain things that we've been given. I just want you to remember your 5 geometry strategies. When you work any type of proof or any type of geometry problem, the first thing that you're going to do is, of course, just always draw a picture. So I drew a picture from the book here. I didn't mean to do that little line inside there, so I'm going to have to get my whiteout out. Okay, so and the next thing you do is that you always put down what you've been given and what you have to prove. So we have those 2 things right here. The third thing is that make sure you label everything, that we have PQ and QR and RS. We have things like QR is a certain value, RS is a certain value. We've been given that QR is congruent to PQ, so we know that these 2 are congruent. We know that RS is also congruent to PQ, so that transitive property thing is going to come in, and all 3 of these are congruent. And we have to solve for X. So generally I kind of go back to my little drawing here and kind of highlight, okay, this guy here is equal to this guy here, and I have to go find X. Let's get over a little bit of the geometry. I know these guys are congruent to each other, so therefore these guys are going to be equal to each other, and we should be able to build a fairly reasonable proof out of this. So we're going to start with the very first thing. That's what happens with every proof. We got to do the given, so I'm going to do QR is congruent to PQ, and RS is congruent to PQ. Very nice. And actually, if we wanted to, we could kind of separate these out, but we don't have to. And the reason why is, of course, because it was given. That's kind of always the first thing. We're good with the first thing, we're good with the last thing. The next thing is that because of what's happening with the geometry here, we know that QR is also congruent to RS. And that's going to be because of that transitive property. And you can abbreviate again, as long as I can be able to tell what you're talking about, it's okay. So be clear in your abbreviations as you do them. What's the next thing that we know here? Well, we know that QR equals 2x plus 5. The whole thing is that we're trying to find x. And that it equals Rx, which is 10 minus 3x. Now, anytime we put something in for something else, that is that we kind of replace things. There's a couple of things that we can do. They called it a congruency property. But personally, I'm okay with the fact that if you take a value and plug it in for something else, that it can also be known as substitution. I don't have any problem with that. It may not be the same as the book, but as long as you pretty much relate that, hey, you plugged something in here, I will accept the fact that it was substitution. All right, so the next statement is that we are going to get, I like to get the x by itself, so that means I'm moving the 5. So I get 2x equals a 5 minus the 3x. And again, if you want to just kind of sideline that a little bit and show what you did, a minus 5 here and a minus 5, I don't have a problem with that either. I'm pretty liberal when we come to these kind of things, as long as you can kind of show me some stuff and the reason why you did what you did and give me a good reason. I'm pretty good with that, because after all, it's all about what you did to get there. And this is going to be the fact that we did the subtraction property. Or what I call, start step number 2, so that's okay. We did the inverse property. Next, what I have now is going to be a 5x equals to 5. And if you want to show your work, it's okay. You're adding a 3x here and you're adding a 3x here. And the reason why we're able to do that was the addition property, or start step number 2. The additive inverse. If you told me additive inverse for either one of these, I'm okay. And next we're going to bring it down to the next one here. Let's see if I can squeeze this all in. X is going to equal 1. And the reason why is because we did division. And if you want to just say the multiplicative inverse, it also works. There's no problem using the algebra that they came up with later to say that that's the reason why. And so, ooh, I put a little 1 there. My bad. It's supposed to be a 6. There we go. Remember that you can add any kind of little mistakes that I made, any phone rings that you hear, cuckoo clocks. Sometimes you might hear the grandbaby cry. Those kind of things, you can always add them in. Just make sure that you give it a nice, great little something here. I heard. La 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 la, what it may be. And I'll be happy to give you extra stars for it. All right. Go out and have an awesome weekend. And share Jesus with somebody. I always love it when people share Jesus with somebody. And then come back and tell me how you did it.